3,000 meters below the ocean surface, sunlight does not exist. It has never existed. Down here, the pressure reaches 300 times what we experience on land, enough to crush a car into a cube, enough to collapse a submarine that isn't engineered to perfection. The temperature hovers just above freezing. No plant can grow. No human can survive unprotected even for seconds. And yet, right now, somewhere in this absolute darkness, a sperm whale is hunting. It has been holding its breath for over 40 minutes. To understand what that means, consider what the whale's body is quietly doing. As it descended, its lungs collapsed, not catastrophically, but deliberately, like a controlled folding. This prevents nitrogen from dissolving into the bloodstream, the same process that kills human divers who surface too quickly. Its ribs are flexible, designed to bend inward under extreme pressure rather than snap. Its blood carries hemoglobin in concentrations for higher than hours, binding and transporting oxygen with extraordinary efficiency. And its muscles are packed with a protein called myoglobin, so densely packed that sperm whale flesh appears almost black, which stores oxygen directly in tissue, giving the whale a reserve that goes far beyond what's held in its lungs. At the surface, a sperm whale's heart beats around 60 times per minute. During a deep dive, that rate drops to 10. The animal is not dying. It is managing. It shuts down everything non-essential, digestion, circulation to the extremities, and redirects oxygen strictly to the brain and the muscles doing the work. It is, in the most literal sense, putting itself into a controlled state of near shutdown, and then swimming calmly back up to breathe an hour later as though nothing unusual happened. No engineering team on Earth has designed anything that does this as elegantly. Now consider the head. A sperm whale's head makes up roughly 1/3 of its entire body length. That square, blunt, almost architectural shape is not random. Inside it sits an organ called the spermaceti, a chamber filled with up to a metric ton of waxy, oil-like fluid. Sound originates deep within the whale's nasal passages, travels through this fluid, which focuses it like an acoustic lens, and fires forward as a directional beam of clicks. The intensity of those clicks can reach 230 decibels. A commercial jet engine at full thrust produces around 140. The difference between those two numbers is not linear, it represents sound energy thousands of times more powerful. Divers who have been near a clicking sperm whale describe feeling it pass through their chest like a physical impact. This biological sonar is how the whale sees in absolute darkness. Each click travels outward, strikes an object, and returns an echo. The whale's brain, the largest brain on Earth, 6 times the mass of a human brain, processes those returning echoes into a 3-dimensional acoustic image of everything around it. Shape, size, distance, movement, even the internal density of objects. A sperm whale scanning you from 50 meters away is not just detecting that you're there. It is building a detailed picture of your lungs, your ribcage, your heartbeat. This is the animal that descends into a world we cannot reach, armed with senses we cannot replicate, to hunt the largest invertebrate on the planet, the giant squid. These creatures can grow to lengths greater than a city bus, and they do not surrender easily. Their arms are lined with suckers ringed by razor-sharp hooks, and the circular scars those hooks leave on sperm whales, some nearly a foot across, were the very evidence that convinced early sailors that sea monsters were real. They were not entirely wrong. They had simply found the monster fighting the monster. For most of human history, sperm whales were known only from the surface, and from that perspective, they looked terrifying. Sailors in the 1700s encountered 15-meter heads emerging from fog, exhaling plumes of mist that carried a sharp, strange smell. Ships sailing through open ocean would hear rhythmic knocking from below their hull, loud, persistent, coming from the darkness underneath them. Crews genuinely believed they were being stalked by spirits, or that their ships were about to break apart. The sound was sperm whales communicating. When commercial whalers began hunting these animals in serious numbers, they found those circular scars on the bodies and became convinced the whales were fighting creatures from mythology. And then in 1820, a whaling ship called the Essex, sailing in the middle of the Pacific, was rammed by a sperm whale, not accidentally, but twice, deliberately, with enough force to stove in the hull and sink it. The surviving crew spent months adrift in open lifeboats. Herman Melville heard their accounts 30 years later and used them as the foundation for Moby Dick. The white whale was not pure imagination. It was the memory of an animal that had decided to fight back. And the fighting back was understandable, because what humanity did to sperm whales over the following century was catastrophic. Inside that enormous head sat an oil unlike anything previously known, the spermaceti oil. It burned cleanly, without smoke. It did not freeze in winter. It lubricated the metal machinery of early industry better than any alternative. It lit entire cities. It was, for a period of time, the most valuable biological substance on Earth, and it powered the Industrial Revolution. Whaling fleets left ports in New England, Britain, the Netherlands, and Japan, crossing entire oceans for months and sometimes years, hunting the same animal across every body of water on the planet. The whales learned. Pods began fleeing at the silhouette of a sail. Mothers placed themselves between their calves and the approaching boats. Some fought back with their tails, capsizing small vessels, dragging equipment underwater. But they could not outrun ships. They could not deflect harpoons. And sperm whales reproduce slowly. A female does not reach sexual maturity until around 9 years old, pregnancy lasts 15 months, and a mother typically raises one calf every 5 to 7 years. A population that reproduces at that rate cannot survive when thousands are killed annually. Some estimates suggest we killed more than 1 million sperm whales. Entire regional populations were effectively erased. Genetic diversity collapsed across the species. The global whaling moratorium finally took effect in 1986, too late for many populations, but just barely in time for the species as a whole. Numbers have slowly recovered. Not to what they were. Nothing close. But enough that sperm whales are no longer on the immediate edge of extinction. They survived. Barely. What we are only now beginning to understand is how much we almost lost, not just an animal, but an intelligence, a culture, and possibly a language. Sperm whales communicate through sequences of clicks called coders. These are not random sounds. They are rhythmic, patterned, and repeatable, almost like Morse code, but infinitely more complex. What researchers have documented is that different populations of sperm whales have different dialects. Whales in the Caribbean produce coders that are structurally distinct from those used by whales near Japan. Pods that travel together develop shared clicking signatures, patterns that identify them to other groups the way an accent identifies a region. This variation is not genetic. It is learned. Calves are not born knowing their clan's coders. They listen. They practice. They gradually learn to produce the right patterns until they get them right. That is not instinct. That is culture, in the precise anthropological sense of the word, information transmitted socially, across generations, through learning. And it may go further than that. Some researchers now believe sperm whale coders have syntax, structural rules that allow different click patterns to be combined in ways that carry different meanings, the way words form sentences. If that hypothesis is correct, then sperm whales are not merely communicating. They are speaking a language, one that has been developing and evolving for at least 15 million years longer than human language has existed. In 2021, the Earth Species Project began using artificial intelligence to analyze thousands of hours of recorded whale vocalizations, looking for patterns too subtle for human researchers to detect. The early findings suggest a level of structural complexity that exceeds what we observe in dolphins, and possibly exceeds the structural complexity of human language, not in what is being said, but in how it is being organized. We don't know yet. But we are beginning to ask the right questions. Sperm whales also live in societies shaped by matriarchy. Family groups are led by older females whose knowledge has accumulated over decades, feeding grounds, migration routes, nursery areas, the locations of safe water that have been passed down from grandmother to mother to calf across generations. These routes through the ocean are not random wandering. They are inheritance. They are memory made geographic. And beyond their social lives, sperm whales physically reshape the ocean around them. When they dive to hunt and then rise back to the surface to breathe, they carry nutrients, particularly iron, from the deep ocean up into the sunlit zone where plankton grow. Plankton form the base of the entire marine food chain and produce roughly half of the oxygen in Earth's atmosphere. A single whale stimulates more carbon capture than thousands of trees. A population of sperm whales can influence climate patterns at a planetary scale. They do not merely live in the ocean. They help maintain it. Even in death, they continue. When a sperm whale dies and sinks to the seafloor, an event marine biologists call a whale fall, it creates an ecosystem. Crabs, eels, deep-sea worms, sharks, and hundreds of specialized organisms colonize the carcass and survive on it for up to 100 years. A single dead whale becomes a century-long city in the darkness, transferring the energy it accumulated across an entire lifetime into creatures that would otherwise have nothing. Life becoming life. A giant becoming a world. When divers have had close encounters with sperm whales in open water, they describe something that is difficult to categorize scientifically but impossible to dismiss. The whale approaches slowly. The clicks begin, softer than expected, deliberate, the whale scanning the diver completely. And then it hovers. It tilts its body to improve the angle of the echoes. Sometimes it circles. Sometimes it produces patterns that sound, to human ears, almost conversational. And sometimes, in moments that have left experienced divers visibly shaken, the whale responds, not to a sound the diver made, but to their presence, their curiosity, their stillness. These are not random behaviors. These are interactions between two animals, from completely different branches of the tree of life, trying to understand each other across an impossible distance. Here is what makes that extraordinary. Sperm whales possess the same neural structures linked to compassion, social bonding, and complex communication that we find in the human brain. They have had those structures for 15 million years longer than we have. We hunted them to the very edge of extinction across 2 centuries of industrialized slaughter. And still, when we enter their world with no weapons and no defenses, driven only by curiosity, they don't flee. They don't attack. They turn around, and they move toward us. Giants with the power to end the encounter in an instant, choosing instead to investigate. Choosing instead to connect. We are only beginning to understand what kind of minds have been living beneath the surface of this planet's oceans, entirely outside our awareness, for tens of millions of years. The deep is vast, and most of it remains unwitnessed. But in the moments when it allows a glimpse, it changes everything.